Okay, get ready. Because today, we're diving deep into the world of math apps. But not just any apps. We're talking about the open source kind that are literally changing how kids in Singapore are learning math. And get this, imagine instead of just memorizing those times tables, you're strategizing to hit target numbers in a card game. Or even like folding and unfolding 3D shapes digitally. That's exactly what we're going to be unpacking today. And it's all based on this super fascinating report we found about this awesome project.
I think it's so fascinating to see how they're addressing this problem of making math,
Yeah,
real and exciting for kids. Because
right.
traditional methods can sometimes feel a bit like, well, just going through the
Yeah,
motions.
totally. Like, why are we even learning this? Where does it apply in the real world? But these apps are like totally changing the game. They're not just worksheets on a screen. There's like full-blown interactive simulations.
Exactly. Take the Telling Time app, for instance. It's so much more engaging than just staring at a clock face. Kids actually get to play around with setting the time to the nearest 5 minutes or half hour. And there's even fun audio feedback to keep them, motivated.
It's like turning a chore into a game. And speaking of making abstract concepts concrete, there's the weighing scale app. I mean, how many times have you wondered how much a pineapple weighs
Yeah.
compared to like a
Or
corn?
this app lets kids explore different units of measurement and visually compare the masses of everyday objects. It's like having a virtual scale at your fingertips.
If you've got like a young builder or architect in the making, the Nets of Cubes app is a must-try. They can digitally fold and unfold 3D shapes. Talk about visualizing spatial relationships. But here's the kicker. It also has a built-in calculator that lets them figure out the cost of materials based on the surface area. Practical math skills in action.
What's really cool is how that app blends spatial reasoning with real-world applications. Kids aren't just learning about shapes, they're understanding how those concepts connect to things like construction or design.
And for those who love a bit of competition, there's the Target Math Addition game. It's like a strategy card game where two players use addition to reach a target number. They can even tweak the difficulty to challenge themselves.
What strikes me about all these apps is the emphasis on active learning. Instead of passively absorbing information, kids are actively engaged, experimenting, and figuring things out for themselves.
Absolutely. And I'm super curious about the process they use to create these apps. The report mentions this thing called prototype-first methodology, which sounds pretty different from the traditional approach.
Yeah, it's a real departure from the typical design process. Instead of spending months meticulously planning everything out on paper, they just jumped right into building working
So
prototypes.
they're all like, let's just build it and see what happens.
Pretty much. They embraced a more iterative approach, constantly testing and refining the apps based on feedback from teachers and students.
So it's like a continuous feedback loop, making sure the apps are actually meeting the needs of the users. That's brilliant. But here's the million-dollar question. What makes these apps so impactful? Why should we care?
Well, for starters, they're designed with this 3A framework in mind: accessibility, adaptability, and affordability. These apps are available for free online on Android and iOS app stores. And the open source code means educators can tailor them to their specific needs.
So they're breaking down those financial and logistical barriers that can often prevent kids from accessing quality learning resources.
Exactly. And think about the potential for global reach. The report mentions they've already had over 59,000 downloads. That's a lot of kids potentially benefiting from these apps.
That's incredible. But downloads are one thing. Does the report mention anything about the actual impact on learning?
They highlight a key finding. Technology can amplify effective teaching practices. So it's not about replacing teachers. It's about giving them powerful tools to enhance their teaching.
So these apps are like a force multiplier for good teaching.
Hmm.
And that brings us to the whole open source aspect. I know you're a big proponent of this model, so why is it so important, especially in education?
Open source is all about collaboration and sharing. Imagine a world where instead of every school reinventing the wheel, they can build upon each other's successes. These math apps are like the perfect example. The code is freely available for anyone to use, modify, and redistribute.
So it's like a giant collaborative toolbox for educators. They can take these apps and tweak them to fit their curriculum, or even like inspire them to create something entirely new. It's a pretty powerful concept.
It is. And the report dives into some really interesting details about the development process. They actually call it hack design thinking.
Hack design thinking. Okay, I'm intrigued. Tell me more.
Well, it's like they flipped the traditional design process on its head. Instead of starting with extensive planning and analysis, they dove right into prototyping.
So less talking, more doing.
Exactly. They created working models of the apps very early on, and then got feedback from teachers and students right away. This allowed them to be much more agile and responsive to what the users actually needed.
Makes sense. It's like getting real-world feedback from the very beginning, instead of working in a vacuum. Did they highlight any specific challenges or surprises they encountered during this process?
One of the biggest takeaways was the importance of truly understanding the users. They spent a lot of time observing how the apps were being used in classrooms, gathering feedback,
Hmm?
and making adjustments accordingly.
So it wasn't just about the technology itself, but about making sure it was integrated into the classroom environment effectively.
Right. And they also stressed the importance of building a strong community around these resources. They actively encouraged collaboration and feedback, realizing that the collective wisdom of the community would lead to better apps.
It's like harnessing the power of the crowd to create something truly amazing. So they built these awesome apps with this incredible community. But how do they actually get these tools into the hands of teachers and students?
They took a multi-pronged approach, making the apps available on their website, the open source physics at Singapore Digital Library, and on the Android and iOS app stores.
Smart move. Cover all your bases.
And did the report mention anything about the response from teachers and students?
They did, and the numbers are impressive. Over 29,000 website visits, almost 10,000 Android installs, and over 20,000 iOS installs.
Wow, that's almost 60,000 downloads. Clearly there's a demand for these types of resources. But beyond the numbers, what were teachers saying about the apps?
Teachers really appreciated the accessibility and ease of use. They found the apps intuitive and well-designed, even for students who weren't particularly tech-savvy. They also loved the adaptability. Remember, these are open source, so teachers can customize them to fit their own teaching styles and curriculums. That's a huge plus. It's not a one-size-fits-all solution. It's a flexible tool that can be adapted to different learning environments.
Absolutely. And of course, the affordability was a major factor. By making them freely available, they could reach a much wider audience and ensure that all students have access to these powerful learning tools.
It's fantastic to see technology being used to level the playing field in education, but I'm curious, did the report delve into any specific examples of how these apps were being used in classrooms?
Yes, they highlighted two really interesting case studies. One involved the Telling Time app, which was used by Mrs. Anna Go at Anchor Green Primary School. She projected the app onto the whiteboard during a whole class lesson, facilitating a discussion about the concepts of time.
So she used the app to create a more interactive and engaging learning experience for the whole class.
Exactly. And then in the last 15 minutes of class, she let the students practice using the app on their own devices. This allowed them to explore the concepts at their own pace and get immediate feedback.
It's a great example of how technology can be used to personalize learning and provide differentiated instruction. What about the other case study?
The other one focused on the Target Math Edition game. Mrs. Teresa Heng used the app during a paired activity, encouraging students to work together and strategize.
So the app became a tool for collaboration and problem solving.
Exactly. And it even sparked some creative thinking. One boy challenged the project team to play the game using only even-numbered cards.
That's fantastic.
Yeah.
It's not just about rote learning. It's about encouraging kids to think outside the box and come up with their own solutions.
Right. And that's what's so inspiring about this project. It's not just about creating apps, it's about creating a movement, a community of educators, developers, and learners who are passionate about making math education more engaging, accessible, and effective.
Okay, but this is all happening in Singapore. What about the rest of the world? Did they mention anything about the global implications of this project?
They did. And this is where things get really interesting. The team, with the help of their Spanish collaborator, Professor Felix, developed a step-by-step guide for publishing mobile simulation apps.
Wait, so they're basically empowering anyone to create and publish their own math apps.
Essentially, yes. They've demystified the process, making it accessible to teachers, students, and anyone with an interest in educational app development. They even provide alternative methods for distribution, like sharing Android APK files directly.
So they're removing the barriers and gatekeepers, making it easier than ever to share educational content. But did they address the role of research in a project like this? I mean, how do you measure the impact of something like this?
It's a great question. They actually argue that focusing too heavily on traditional research methods, like controlled experiments, might actually slow down the development of these apps.
That's interesting. I would have thought research would be, crucial to prove that these apps are effective.
Oh, they definitely see the value of research. But they also emphasize that in a fast-paced project like this, it's more important to focus on creating useful and relevant apps that people actually use. They believe that the widespread adoption of these apps, with thousands of users providing feedback and sharing their experiences, is a form of evidence in itself.
It's like crowdsourced evaluation.
Yeah.
If thousands of people are finding these apps valuable, that says something, right?
Exactly. They even encourage anyone and everyone to try out the apps and form their own conclusions about their effectiveness.
It's a really open and inclusive approach. It's like they're saying, here are these tools, see what you can do with them. It's pretty empowering, actually.
It is, and that's what makes this project so inspiring. It's not just about creating apps, it's about creating a movement, a community of educators, developers, and learners who are passionate about making math education more engaging, accessible, and effective.
It's a beautiful vision, isn't it? A world where learning is no longer confined to textbooks and classrooms, but it's happening everywhere, powered by technology and fueled by the collective creativity of a global community.
It's a future worth striving for, and this project is a shining example of what's possible when we embrace the power of open source, collaboration, and a relentless focus on creating tools that empower learners.
This has been an incredible deep dive. We've explored the fascinating intersection of math, technology, and education, uncovered the secrets of open source development, and witnessed the transformative power of a shared vision.
And it's just the beginning. The world of open source education is vast and constantly evolving. Who knows what other innovations are out there, just waiting to be discovered and shared with the world.
So what do you think? Could this open source approach revolutionize the way we learn? And what other areas of education could benefit from this kind of collaborative innovation? We've only scratched the surface. But this deep dive has definitely sparked a lot of exciting questions.